In this video, we're gonna go over the product and quotient rules. Alright, so we're gonna start with the product rule. And the product rule says that if you have a product of two functions, say f of x and g of x, then you want to keep your first function and you differentiate your second function, plus you keep your second function and you differentiate your first function. Now, another way that you might be taught this is that d by dx of uv is equal to u dv by dx plus v du by dx. So whichever way you prefer, way 1 or way 2, that is alright. So we're going to be using this formulas. Alright. So I hope you can take some time to note this down. So I'm going to do again all the... Okay, so let me do AC, DF, and GI, and I'll leave B, E, and H for you. Alright. So question A is x minus 2 to the power 5. And we need to find d by dx. So what you can do is you can say, hey, if it's a product of two functions, right? This is one function, this is another function. So you can write u, just pick u to be x and v to be x minus 2 to the power 5. Now you know that du by dx, if you differentiate this, you just get 1. And dv by dx is, so using the chain rule, you get 5x minus 2 squared d by dx of x minus 2. And this will just give you 1, right? This part will just give you 1. So you just have times 1, so that is just going to be 5x minus 2 to the power 4. And finally, your solution is u dv by dx plus v du by dx. And that is, so u is x, dv by dx is going to be this expression. So when you put them together, you're going to get 5x x minus 2 to the power 4 plus v is this expression. And u is just 1. du by dx is just 1. So overall, your final solution is this expression. And that is it. That is your final answer. Let's see. So I was doing question 1a. So the textbook prefers to write it differently. So let's see. You can factor out ax minus 2 to the power 4, right? That is the highest power that you can factor out. And you have 5x here, and you have x minus 2. Sorry, you have 1 here, I think, right? Sorry, no, you have x minus 2 here. Because this times this will give you the first term, and this times this will give you the second term. So you effectively have 6x minus 2 times x minus 2 to the power 4. That is your final solution. So this is how the textbook presents it, but this is also correct. Alright. So we're done with A, and I'm going to erase everything. So I hope that you have taken a note of the formula that we're going to be using. Alright. So we're done with A. Let's do C. So C, I have d by dx of x times square root of x plus 2. And now let's do it the old way. The way that I'm probably going to be doing it in future videos is I'm going to do it directly. So I keep my x. I will differentiate square root of x plus 2. I will keep square root of x plus 2. And I will differentiate x. So x, differentiation of this using the chain rule, right? So I can write this as x plus 2 to the power half. And when I differentiate, I get half x plus 2 to the power minus 1 by 2 times d by dx of, was it any x dega made, right? So x plus 2. So that is the derivative. Plus d by dx of x is just 1. So we're just going to have x plus 2 left here. And if you simplify everything, so this will just give you 1, right? If you simplify everything, you get x over 2 square root of x plus 2 plus square root of x plus 2. And another way you can write this is x plus 2x plus 2 divided by 2 square root of x plus 2. So that is, I'm going to leave you to figure out how to get a common denominator here. But overall, your answer is going to be 3x plus 2 over 2 square root of x plus 2. And that is your solution to C. Sorry, 3x plus 4, because 2 times 2 is 4. Over 2 square root of x plus 2. Alright, so that is your solution to C. Your solution to D, right? D is just x minus 1, x plus 5. And you can do it uv again, whichever you find easier. U is just x minus 1. Du by dx is just going to be 1. V is square root of x plus 5, which is x plus 5 to the power half. And dv by dx is just going to be half x plus 5 to the minus half. And x tega made, so d by dx of x plus 5 will just give me 1. So this is my solution. 5, right? So your solution, final solution, is just u dv by dx plus v du by dx. So u is x minus 1. dv by dx is 1 over 2 square root of x plus 5. Plus v is just square root of x plus 5. And du by dx is just 1. So times 1 is the same expression. So I get x minus 1, 2 square root of x plus 5, plus 2x plus 5 divided by 2 square root of x plus 5. So I just took a common denominator on both sides. So I'll leave you to figure out how we can go from this expression to this expression. So x plus 2x is 3x, minus 1 plus 10 is plus 9, divided by 2 square root of x plus 5. So that is going to be our solution. 3x plus 9 divided by 2 square root of x plus 5. So if you're wondering how I got here, so it is as follows. So I take this, I multiply, and I divide by square root of x plus 5, right? And that will give me in the numerator x plus 5. And then I multiply and divide by 2. So that is how I went from here to here. Alright, so we're done with D as well. Let me erase everything so I have more space. So F. Sorry about that. F, I have square root of x, x squared plus 2 to the power 3. So this is more tricky, but still nonetheless very easy. So d by dx of this expression, right, is going to be, you keep your first function, u, d by dx of v, right? X squared plus 2 to the power 3. Plus, you keep your second function, you keep your v, and then you take d by dx of square root of x, right? V du by dx. Alright, so you have square root of x. Now you do the derivative here. So you can bring 3 out in front. You decrease the power by 1. But ani x tega made. So you have to differentiate it again. Alright. Times, when you differentiate this, so this is just x to the power half, right? You are going to get 1 over 2 square root of x. So remember, d by dx of square root of x is always 1 over 2 square root of x, and d by dx of square root of x plus any constant a, whether it's plus or minus any constant a, is still going to be 1 over square root of x plus or minus a. So this is something you might want to remember. So we get this using the power rule, and I think I've already shown you how we get here. Alright, so square root of x, we have 3x squared plus 2 squared, 2x plus x squared plus 2 cubed, 2 square root of x. Alright. And now maybe, let's see. Do I want a common denominator? Probably. But let's simplify first. So 2x to the power 3 over 2. I multiply these together. And when I multiply by 3, I get actually 6 here. So I get this expression. And then, sorry, this is my first term. X squared plus 2 cubed over 2 root x. Alright. So now I multiply and I divide by 2 root x. So if I do 2 root x and I divide by 2 root x, so I get the same denominator, I'm going to get the expression 12x squared plus 2 squared divided by 2 root x plus x squared plus 2 cubed divided by 2 root x. Alright, so now I can factor out x squared plus 2 squared from the numerator, and I will get 12x squared plus x squared plus 2. And 2 root x in my denominator. So you can just factor out the lowest power here, and you are going to get this expression. And you get x squared plus 2 squared. You get 13x squared plus 2 root x. So that is going to be your solution, probably in the simplest form. All right, yeah, that is it. That is also how the textbook presents it. So we are done with F. All right. So this is your solution to F. Let's go ahead with G. So you have x minus 3 squared, x plus 2 squared. So let's use the UV method. If I say u is x minus 3 squared, du by dx is just 2. So I'm using two different methods here. As you've seen, I'm doing it directly as well, or I'm separating it out. Whichever you find easier, you can use. So 2x minus 3. And you can use the chain rule to do the differentiation. This is something we have done before, so I'm just going to do it very quickly. Alright, so now your solution is u dv by dx plus v du by dx, right? So finally, you get your answer 5x plus 2, 4 plus x plus 2, 5, 2x minus 3. So therefore, your solution is 5x minus 3 squared, x plus 2, 4, plus 2x minus 3, x plus 2 to the power 5. That is your solution for G. And you can factor stuff out, actually. So you can factor out x minus 3, and you can factor out x plus 2 to the power 4. And if you do so, you have 5x minus 3 from the first term. So if you factor out these two terms, right, you're going to get 5 times x minus 3 plus 2 times x plus 2 inside. And you can simplify inside here. So you get 5x plus 2x is 7x, minus 15 plus 4 is minus 11. So you get this expression to be your final answer. But you could stop here as well. This is also correct. This is just a more simplified version of that. Both are correct. And let's go with I. So for I, you have 2x minus 5, 3x squared plus 1 squared. So you can use the UV method. U is just 2x minus 5. Du by dx is going to give you 2, right? V is 3x squared plus 1 squared. dv by dx is going to be 2, 3x squared plus 1 to the power 1. But ani x dega made, so you have to differentiate it again. So overall, this is 6x. So it's going to be 12x, 3x plus 1. Yeah. This is, when you differentiate this, you're going to get 6x. So when you multiply everything together, you get this expression. So now, finally, your answer is going to be u dv by dx plus v du by dx. So u is 2x minus 5. dv by dx is this expression. So it's 12x, 3x squared plus 1 plus v is this expression, which is 3x plus 1 squared. And du by dx is just 2. Alright, so you have 12x, 2x minus 5, 3x squared plus 1, plus 2, 3x plus 1 squared. And we can factor out 3x squared, I believe, right? Yeah. Okay, so 3x squared. So we can factor out 3x squared plus 1. And we get 12x, 2x minus 5, plus 2, 3x squared plus 1. And inside the bracket, if I factored out this expression, I'm going to have 24x squared minus 60x plus 6x squared plus 2. So that is 30x squared plus 2. And you can factor out a 2, I believe. 3x squared plus 1. So you get 15x squared minus 30x plus 1. Alright, so I'm trying to simplify as much as the textbook does. So this is your final solution. But leaving it here should also be okay, to be honest. Alright, so let's do question 2. Find the gradient of the curve at this point. So basically, you want to find dy by dx, which is going to be d by dx of x squared square root of x plus 4. So pick a u, pick a v, and you can switch the order. It's okay. It doesn't matter which one you pick u and which one you pick v. So du by dx is 2x, dv by dx, and I gave you the formula, is 1 over 2 x plus 4. So now you can just write your solution. Your solution is u dv by dx plus v du by dx. Alright, so u dv by dx is going to give us this times this is going to give us x squared by 2x plus 4 plus v du by dx is going to give us 2x x plus 4. And we don't need to simplify this further, actually, because we are asked to find at a specific point. We are asked to evaluate this at x is equal to minus 3, right? Minus 3. So we just substitute minus 3 here. So if you do so, you will get 2 times square root of 1 plus minus 6. Minus 3 plus 4 square root of 1. Okay. So 9 times 2 minus 6. So minus 12 by 2 is going to give you minus 3 by 2. Yeah, minus 3 by 2 is your solution, which is also minus 1.5 according to the textbook, which is the same thing. All right, question 3. Find the x coordinate where the gradient is 0. So you just want to find dy by dx. So pick a u and pick a v. This is u. Du by dx, you use the chain rule. 3 minus x squared, but any x tega? No, right? So you differentiate. Always use the chain rule so that you don't make a mistake. So if you simplify, you're going to get negative 1 here, actually. So minus 3 minus x squared. That is going to be your answer here. And v is just x plus 1 squared. You're going to get dv by dx. It's going to be 2x plus 1. Any x tega, madhe, so you have to differentiate it. And this gives you a positive 1, so I don't care. 2x plus 1. So now your solution is u times dv by dx, right? Is going to be u times dv by dx, which gives me this expression, plus v times du by dx. So that is minus 3x plus 1 squared, 3 minus x squared. So I can do some factorization here. I can factor out 3 minus x squared and x plus 1. And from the first term, I have this expression, right? And from the second term, I have this expression, I think. So if you factor out these two things, if you multiply these back in, then you should be getting this expression. So I factor out the lowest power of both terms. So the lowest power of 3 minus x is this power, and the lowest power of this is x plus 1 is, you have a square here, you have power 1 here. So we're going to factor out the lowest powers. So if you simplify, inside here, you're going to get 6 minus 2x minus 3x plus minus 3, right? So that is minus 5x plus 3, I believe. If you simplify, you get minus 5x. So basically 3 minus 5x, right? And we need to solve this for 0. And that is quite easy, right? You can see that, hey, the first term, you equate it to 0. 3 minus x is equal to 0. That means 3x is equal to 3. You can equate the second term is equal to 0. So x is minus 1. And you can see that the third term, which means x is equal to 3 over 5. So those are the three solutions. So minus 1, x is 3, and 3 over 5. Those are your three solutions. So we're done with 3. And finally, question 4. It's the same type of question, right? All right. So question 4, you have y is equal to x plus 2, 1 minus 2x. So dy by dx. So let's just pick u and v. U is x plus 2. So du by dx is just 1. V is 1 minus 2x. dv by dx. Now, I don't want to use the formula that I gave you directly. Why? Because when you differentiate the inside, you don't get positive 1, right? So dv by, basically, if you want to find dv by dx, then that is the same as finding d by dx of 1 minus 2x to the power half. And when you start solving, you get half 1 minus 2x to the power minus half times, if you differentiate the inner functions, you get minus 2, right? Ani x dega made, so when you differentiate whatever is inside, you're gonna get minus 2. And this is gonna cancel out, so your final answer is 1 over square root of 1 minus 2x. Alright. So now, u dv by dx is gonna be this value, right? If you multiply those two things together, you get this. Plus, v du by dx is gonna give you this. Alright, so this is dy by dx. Now, let's simplify so that they have a common denominator. And if I do so, I'm going to get minus x minus 2 plus 1 minus 2x divided by square root of 1 minus 2x. And I just multiplied and I divided by square root of 1 minus 2x to get this expression. Alright, so I have minus 3x minus 1 in my numerator. In my denominator, I have this expression. So I need to solve for this is equal to 0. So my denominator can never be 0. Whenever you have a fraction, your denominator can never be 0. So minus 3x is going to be minus 1. So your numerator has to be 0. And x is just going to be negative 1 over 3 if you solve this equation. Yeah, that is it. That is the x-coordinate of the point. So it just says x-coordinate, so I can leave at just the x value. Where the gradient is 0 is negative 1 over 3. And that is it for this topic.